Hi everyone, welcome to our second video for week 5 of Kines 6770. So we're going to be talking about the second part of the assignment for chapters 8, 9, and 10, where we're going to be looking at the spread and gather functions as part of the tidyverse library. So in these exercises, which are in chapter 9 on page 156, it asks us first why spread and gather are not perfectly symmetrical. And then it gives us some code to consider. And you're going to need to run those bits of code in order to understand why we get slightly different results if we take our original stocks data frame, spread it, right, to go from wide format to long format, or sorry, to go from long format to wide format, and then gather it back together to go from wide format to long format. So we have the code in the book. I think in order to answer this question, it's going to be really helpful, though, to break that code into a few different pieces so that you can see what it's doing each step of the way. So starting on my it's line 59 here of my code, we're looking at why spread and gather are not working symmetrically. So first, we'll use the code to create the data frame stocks. And I'm going to print that to the screen so we can get a good sense of what it looks like. You can see that we have 2 years worth of data, 2015 and 2016. We have 2 observations per year because it's split in half. And then we have the returns on this hypothetical stock for each half of that year. Okay, so if we want to first see what happens when we spread stocks, we can run this push stocks through a pipe into the spread function. And you can see that we are spreading it by year where the dependent variable is return, right? So year is the key, the value is return. And what we have then is the wide format version of our data that was previously in a longer format. So now we only have 2 rows, right? But we have 3 columns where we have our returns then in 2015 for the first half here, 2016 for the first half here, and then the second half of each year on the second row of data. So if we spread this out, we go from years, halves, and returns into just rows that represent halves and columns that represent the 2 different years. So now let's say we want to take this and gather that back together to transform this from the wide format data into long format data again. So again, I'll push stocks through the spread function, but then I will push that through a pipe and into the gather function, in which our key is the year and the value is that we will now relabel as returns. If I do that, you can see that I get something slightly different from my original data frame. It has the same dimensions, but now half is the first column and year is the second column. You can contrast that with what we had before when we originally had the stocks tibble, right? Year was the first column, half was the second column, and then we had our returns. So why does this do this? Well, the answer is because gather doesn't actually know our column numbers. It knows which one is the key variable and which one is the values variable, but it doesn't actually know from the original data frame in this case which column came first. And really we can represent the columns in different orders as long as the rows are all still related to each other, right? So we still have the values for the first half of 2015 are all still associated. The values for the second half of 2015 are all still associated. So those bits of information stay together. But when we take our data frame, spread it out, and then regather it, the gather function doesn't have a way of knowing exactly what order those columns were in to begin with. Another more subtle difference is that you can see that the year variable has now changed to a character vector when before it was a double, right, or a numeric vector. So it has changed. It's been converted into a different class of variable as a result of spreading it out and then gathering it back together. In order to do this, we can add an optional argument to our gather function, which is we can say convert equals true. And when we specify that convert equals true, it's going to convert the variable type based on the type of information that's in there. And because all of the values within the year column are going to be numeric, it will turn it into either a double or an integer, depending on if there is a decimal place in any of those data. So if I take stocks, spread it out, and then gather it back, and I specify that convert equals true, you can see that again my columns are out of order still, but now the year variable is indeed represented as an integer rather than a character because I've converted it based on the type of information that was visible in that column. So by specifying convert equals true, I'm going to be more likely to have variables classified the way that I want based on the type of data that I have. So that should give us enough information, right, to answer this first question. We can see why those variables then get jumbled up when we regather the original data frame. Next, we want to look at why a particular piece of code fails. So in order to do that, right, we are going to create the data from the book. So we have these individual names, right, as a function, and we have a key that tells us what their age and heights were, and then we have a value for each one of those variables. Now, we can see that this code fails when we try to spread it as a function. So people is our data frame, key is the name of the key variable, value is the name of the value variable, and we can try to spread it. And you can see that we get this error message. So what we need to do in order to solve that problem is add a column that specifies unique observations within our data. And in looking at it, this was not overly evident to me at first, right? But the actual problem is that we don't have unique observations here. We have a Philip Woods with an age of 45, a Philip Woods with a height of 186, but then we have another Philip Woods with the age of 50, right? So probably unlikely that you're going to have two individuals with exactly the same name in your data set, but it's possible, especially if you think of this not as necessarily two individuals, right, but two observations. Maybe these are the names of certain conditions in your experiment or blocks in your experiment. And we now need to know, okay, this is Philip Woods and age, so we think these things go together, but this is also Philip Woods and age. So we don't know, does the 50 belong up here or does the 45 belong down here when we're spreading these data out or trying to gather them back together. So in order to do that, we're going to need to add some sort of unique identifier that will help us keep all of those bits of information together. So the easiest thing that we can do in this circumstance is add a new variable which will represent each row uniquely. So to do that, I'm going to create a new data frame called people2. I'm going to take the original people data, I'm going to push it through the group by function, then I will push it through a pipe into the mutate function, and I will get a new variable which is called observation, and that's equal to the row number that we're currently on in that data set. So you can see then, okay, I go through this for the first time, I would go through this in my group by, right? So I'm looking at Philip Woods age. This is the first instance of Philip Woods and age, so it's going to get row number 1. Then I have Philip Woods height. That's the first instance of Philip Woods and height, so it's going to get an observation number 1. Then Philip Woods age, this is actually the second instance of this, right? So because I grouped this by name and key, we now can say this is the second Philip Woods age value that we had in this data set, so it's going to get a 2. Okay, and then Jessica Cordero gets a 1 for height, or 1 for age, and also gets a 1 for height. So now by adding that value to our spread function, by adding that value to our data, we can get a spread function that actually works. So now you can see that when I spread people2, which has that additional column for an observations value, it now spreads those data out correctly. So for Jessica Cordero, she had 1 observation for age and 1 observation for height. For our first Philip Woods, he had 1 observation for age and 1 observation for height. For our third Philip Woods, we only had 1 age observation. So the height column correctly gets a missing value there. So by adding that additional column, we can now get the spread function to work because we actually have unique identifiers that keep all of the different pieces of information correctly associated. All right. So next, we move to the exercises in 9.3 on page 160. So in those exercises, we want to learn what the extra and fill arguments do inside of the function separate. So separate can be really useful when we're trying to take data that's inside of one cell and break it apart into multiple pieces of information. So the book gives us a few different examples of tibbles that we want to then try to separate, and we want to see what happens in each of these circumstances to understand what the extra function is doing and understand what the fill function is doing. So in R, we can start by creating these tables. So I'm going to create the first tibble, and I'm going to assign it to an object called dat1. Right? So you can see this is our first data set. I have a variable called x that's made up of 3 character objects. Right? The first one is ABC, the second one is DEFG, and the last one is HIJ. So if I want to break those apart, I can push dat1 through a pipe into the separate function, where I will take the variable x, and then I will separate it into 1, 2, and 3 components. And you can see that then I have 1, 2, and 3. So I've given it 3 elements. So R is going to know to separate this into 3 different columns. And I'm telling the names of these things refer then to the labels that I give those columns. Right? So for instance, this doesn't have to be 3. I could call this like X, Y, Z, right? And we can see then what we get when we run that code. You can see I get 1, 2, and X, Y, Z, right? So it doesn't actually have to be 3 here. The key thing is that we're giving the separate function 3 elements, so it knows to break it into 3 columns, and then it will label those columns based on the values that we put in here. But we also see then that we get this error message where it says it expected 3 pieces, additional pieces discarded in 1 row, and specifically in row number 2. Right? Our original row number 2 should have had D, E, F, and G, so that G is an extra element that it doesn't know what to do with. We only get to D, E, and F, and then G has been discarded. Right. Similarly, we have the option of looking at this other tibble, which I will call dat2, where for our second row, rather than 4 elements, we're actually only going to have 2. So in this case, our second row is actually missing an element, right? The other 2 still have 3, but the second row only has 2. And if I run separate in that case, right, it's going to put an NA in that third space, and again I'll get an error message, but rather than extra pieces, it's going to say expected 3 pieces, missing pieces filled with NA in 1 row, and specifically in row number 2. Okay, so in this case, it's filling this in and giving us an NA here. Now, that might not be exactly what we want in either of those circumstances. We don't want G to just be dropped. And do we know that we necessarily want this third character to be blank in the case that we have missing observations? So in order to control the behavior of the separate function, we can either use the extra argument or we can use the fill argument. So the extra argument tells R what to do with extra data values. Okay, so when we're pushing dat1, right, where we have 4 values, so we have 1 extra value, we're going to try to put it into 3 columns, and then if we want to drop that extra one, we can specify extra equals drop. You can see now that we don't get an error message for dropping that letter G because we've told R explicitly that we want to drop any extra elements. Alternatively, we can use extra equals merge, and you can see that then R is going to append any extra elements into that last column. So we can force it then to say, okay, we got to D, E, and F. Wait, there's only supposed to be 3 things. So we're going to assume then that we'll take the first 2 and keep those separate, and then everything else must really be 1 element, so we stay at the 3 things we want to have. Alternatively, if we have missing values, we can use the fill argument. Okay, so fill is a lot simpler to understand. It just tells us where to put the NA when we have a missing space. So for instance, if I say fill equals right, you can see it puts the NA in the rightmost column. Whereas if I say fill equals left, and the next bit of code, it's going to put the NA in the leftmost column. So extra and fill are arguments inside of the separate function that tell you how to handle extra values in the case of extra, or tell R how to handle missing values in the case of fill.